course. Hi, guys. Okay, so this is 4.2a, and so we're into 4.2. 4.2, the objective is all about pretty much dividing polynomials, and it's going to be new. Be prepared to have to persevere. Okay, so our topic, long division of polynomials, and our objectives. I can use long division to find the quotient and remainder of two polynomials. I can use the remainder theorem when dividing by a linear factor x minus c. So let's flash back to long division. I told you this. If you can connect dividing polynomials to just dividing numbers without x's and y's and alphabets, it'll be easier on you. So try to be connecting all the time. So we're going to find the quotient and remainder of 91,823 divided by 4. You got to write small so we can squeeze it in. You know how long division takes up the whole paper. At least I'm dividing by a single digit, and we're not dividing by 159. That's the worst. That's when I get out my calculator. I swear, the thing I hated the worst in 4th grade was long division. Ready? Process. So we're thinking about process here. I know this is so like elementary, but process, because we're connecting to our new process. 4 goes into 9 2 times, okay? And then we multiply, and we subtract. And then we bring down the 1. And we start over. 4 goes into 11 2 times. 2 times 4 is 8. And we subtract 3. And we bring down the 8. And we start over. 9. I like it. 9 times 4 is 36. We subtract. That's 22. Bring down the 2. 4 goes into 22 5 times. 5 times 4 is 20. We subtract. That's 2. Bring down the 3. I am out of space. 5 times again. 20. Remainder. There it is. Okay, so this is the process that we're going to go through. Now, it's a little bit more involved than that, but it is the same idea. Let me ask you this. If I told you to do this, 12 goes into, we'll do an easy one like that. First we go 12 goes into 1. Does that work? So then we go 12 goes into 15, right? And we put the quotient above the place value where we stopped, right? So that's 12. And we subtract. And we do 37. How many 12s are in 37? Okay, 3. Pause the video because we got to. How many times 3? 36. And you guys probably finished the problem while that happened. And then we bring down the 13 and it goes, and I picked something that wasn't too awful. Right? But the whole point of that was that when I went 2 terms in, I went 2 terms in before I wrote my quotient. Remember that. Okay? So today, we're going to be dividing polynomials. Same kind of idea. You know how in this place, when we were up here, we put the 10,000 in the 10,000s place, and the thousands place, and the hundreds place, and the tens place, and the ones place, and we lined up our place values, right? That's what you do in division. So when you're doing polynomials, you line up your exponents, 7th powers, 6th powers, 5th powers, and you always keep all of your degrees or your powers lined up. So that's important to know. So here's why that is important. Make sure that your functions are written in descending order of exponents. Fill in all missing terms with 0 times x to the missing exponent. Whatever it is. So like, for example, if I have 2x to the 3rd minus 2x plus 1, well, that's in descending order, but it needs to be descending exponent 3, exponent 2, exponent 1, exponent none. So if I were to fill this in and rewrite it, I would write it 2x cubed plus 0x squared, because there aren't any, minus 2x plus 1. Okay, so it's really important, especially when you're just starting out with this. After you get a little more proficient, you can kind of just skip over and just make sure you keep all your exponents lined up. But for now, we're going to use it as a placeholder. Okay, so that's important. Then divide first term into first term and ignore the rest. Don't try to do any other divisions. Just do first term divided by first term. That's it. Remember to change all the signs during the subtraction step, because you'll be subtracting like a binomial or a trinomial, so you have to distribute the subtraction. So that's really important. A lot of people forget that. Then bring down the next term and go again until you brought down all the terms. Your last subtraction will be your remainder. Please remember to write your remainder over your divisor. Okay, so this is the process we're going to go through. So here we go. Now, if you recall, when we did our little key terms and ideas, we found the remainder of this. You remember what the remainder of this was? 7. Okay, well, let's see if that's true. So first I'm going to do step 1. Are my functions written in descending order of exponents? 2, 1, none. 1, none. Nothing missing. Okay, so this is like doing a 2-digit number into a 3-digit number. Okay, that's what that's like. So we're going to do, all right, x minus 7 goes into x squared minus 3x minus 21. That looks terrible. There we go. Okay, so we didn't have to fill anything in. X squared, x to the first, constant, beautiful. So here's what we do. Next step says divide first term into first term. So I'm doing x squared divided by x. Now here's what your goal is with this. It's a little bit different. This is kind of different than when we're doing division of other things. Your goal is to get x squared to cancel out to be 0. When you do your subtraction, your first term cancels out completely. So I always tell people when they're first learning, what you do is just come over here to the side and do x squared divided by x and get the solution to that. What's x squared divided by x? X. So I got to line that up right here in the x column. And see, that's 2 terms anyway, so I need to go 2 terms in to put my quotient. Now here's what you do. That was divide. Now we multiply, and you have to distribute because you're multiplying x times a binomial. So that's x times x is x squared, and x times negative 7 is negative 7x. So there's your multiplication. So we divided, we multiplied. What's the next step? Subtract. But listen, guys, pay attention. We are subtracting a quantity, 2 terms. So you know what we got to do? You got to distribute that. So I just say change all the signs. So I'm going to change this to plus. I'm going to change that to minus. And I'm going to change that to plus. That's though, if you're going to mess up anything, it's going to be that. You're going to forget to change your signs because you're subtracting a quantity. Now, this is what needs to happen. If this doesn't happen, you've done something wrong. X squared minus x squared is gone. That first term has to be eliminated when you're doing this properly. Then you add your next terms. So negative 3x plus 7x is 4x. And then we bring down minus 21 and we start over. You with me? All right. So again, we go first term into first term, or 4x divided by x. Ignore the plus 7. Ignore the minus 21. I don't care. I'm just trying to get the 4x to eliminate. So what's my solution? 4x divided by x is? Yeah, but it's a positive 4, yeah? So I'm going to write plus 4 because it's a binomial. Okay, so we multiply. 4x and negative 28, right? Because you're distributing. Of 4 times x minus 7. Okay. And then we are, next step, subtracting. So if I go grab my other color, remember what I do, distribute. So that's going to become a plus, that becomes a minus, that becomes a plus. Change all your signs. Okay, and here's what's supposed to happen. So this, we're still on the right track. Negative 21 plus 28 is, oh, what was our remainder supposed to be? Look at that, it happened. Okay, so now we're going to write our remainder over our divisor, and here's how you do it. You come up here and you go plus 7 over x minus 7. Yeah, I can't remember to do the plus because you've written a whole new polynomial. Actually, it's not a polynomial. That's like a rational weird. That's a rational because you have an x in the denominator. That's the answer. Any questions? Oh my gosh. Can we close the door, please? Anybody have questions? Yes. What number? These values? Okay. So that's a good question. Okay, so we have two terms here. So we start by dividing into these first two terms here. But I don't even look at the negative 7 or the negative 3x. I just divide x squared by x. It's the first term in the dividend by the first term in the divisor. And I am trying to, this is my goal, is to get x squared when I multiply. Because I want to be able to do x squared minus x squared and cancel out that first term completely. So it's always just pay attention. You're doing that number goes into that number. And then on the next step, your focus now is on this first term. So you're doing x goes into 4x positive 4 times. But again, you want to write 4x over 4x so that you can cancel that term out. Does that answer your question? Gio?
So x minus 7, if you don't pay attention to minus 7.
No, because that's always an afterthought. First term into first term, that's your focus. The rest of the stuff is just part of your remainder. Okay? Anything else? Okay. Let's go on to this next problem then. This is a little more complicated. Find the quotient or remainder of f of x divided by p of x. I think I need to scooch that up just a little bit. All right. So here we go. So I'm looking at this, and first thing I focus on is, do I need to fill in any place values? Cubed, 3, 1, none. I need the 2. And here I have 2 and then none. I need the 1. So I would do this. 2x squared plus 0 x's, there aren't any of those, minus 1 goes into 3x cubed plus 0x squared, because there weren't any of those, minus 2x minus 3. So maybe circle that you're kind of filling in or something, because you got to get all your place values in there. All of your exponents have their own place in the equation or in the process. Okay, so here we go. We are trying to get this to happen. This is what we want. Okay? So we're going to focus on 3x cubed divided by 2x squared. And it's not quite as easy to see as the last one was. Okay? So here's what I suggest we do. We come over here and we go 3x cubed divided by 2x squared, and we simplify it as much as we can. So what can I do with my x's? How many on the top can I cancel? 2. So that would just be x, right? And on the bottom, they both cancel out. So here's what I have. 3/2 x. That's what I have. And let me just check that real quick. Is 3/2 x times 2x squared equal to 3x cubed? Yeah, because 3 times 2 is 6. 6 divided by 2 is 3, and x times x is x cubed. So that works. So I'm going to multiply. So 3/2 x is the divisor, the quotient that I'm looking for. And it's an x to the first power, so it goes right here. Because you've got to keep your exponents lined up. And look, that's 3 terms into 3 terms. So it's going to go above the third term. That's how division works. Okay, so we multiply. 3/2 x times 2x squared is 3x squared. 3/2 x times 0x is what? 0 times, I got to keep my x squared in there because I'm trying, it's 0x squareds, right? There aren't any. That still says 0, doesn't it? Yeah, okay. And then 3/2 x minus 1, or times -1 is -3/2 x. Okay, so those dang fractions are always throwing us off. All right, so we're going to subtract this quantity, which means we're going in to change the signs, right? Plus, minus, minus, plus. And then we subtract. So we did what we wanted. Here was our ultimate goal, was to get those two numbers to cancel out and to get rid of the cube. We're done. Then in this section we have 0x squareds minus 1/2 x, and bring down the minus 3. Yeah. Yeah, I don't mind if you use decimals. Okay. Last step. We're going to go 2x squared goes into 0x squared. Or 0x squared divided by 2x squared. What's that? 0. So we'll go plus 0. We got to hold that spot. We still have to do some math. But when we multiply this whole thing times 0, we get 0x squareds plus 0x's plus 0. And I don't really need to change the signs of that because adding 0, subtracting 0, same thing. Right? I just go in and go, okay, minus, minus, minus. Cancel that out because that's what was supposed to happen. And we get -1/2 x minus 3. That's our remainder. But I am going to give you a little advice. I don't like that. Because the lead is negative, I suggest we factor out a -1 plus 3. So when we write our remainder up here, we'll write minus 1/2 x plus 3 over our divisor over here, 2x squared minus 1. And actually this plus 0 is really kind of superfluous. So final answer, let's just do this. 3/2 x minus 1/2 x plus 3 over 2x squared minus 1. And there's your quotient and your remainder, with the complication of having to fill in the zeros. And you might have to plug in multiple zeros. I don't know. Happens sometimes. Questions about that? Hopefully your comfort level gets a little higher, a little higher. Okay. Last one then. Here we go. Find the or last two. The last one goes really fast. Okay. So find the quotient and remainder of f of x divided by p of x. First thing I ask myself is, do I have to fill in any missing exponents? 2, 1, none. 2, 1, none. Okay. And we're doing an x squared divided by x squared, which means my answer is going to be a degree of 0. X squared divided by x squared is 1. No x left. 3 terms into 3 terms. We only have to divide one time. So we're going to do x squared minus 3x plus 2 goes into 3x squared plus 4x plus 11. And we begin. Remember, you're doing 3x squared divided by x squared, ignoring everything else. It's all part of the remainder. So what is the answer to that? 3x squared divided by x squared. Positive 3, right? All right, so 3. So we multiply. So that's 3x squared minus 9x plus 2. 6? I said plus 2. It's 6. And we are now subtracting that whole quantity, which means we're going back in to distribute that subtraction. So we're going to change all the signs. Plus, minus, plus, minus. And we were successful because look what happens in our first place. In the squared place. Cancels out. So we get 13x plus 5. And that is the remainder because there's nothing left to bring down. And the remainder, notice that the remainder has a degree lower than the divisor. That's supposed to happen. So what's our remainder? There it is. Beautiful. Usually when you do the same degree divided by the same degree, when the degrees that you're dividing are the same, it's pretty fast. You only have to do one division. Okay, last question. Find the quotient and the remainder of f of x divided by p of x. F of x, notice how many terms is it missing? 1. P of x, how many terms is it missing? Like a lot. But here's what I want to ask you. So this has, if I expanded it all the way out, it would have 4 terms, right? If I expanded this one all the way out, it would have 8 terms, right? Right? So that's like me saying, okay, guys, here's what I want you to do. I'm going to do a numerical example to illustrate. 3, 5, 6, 1, 2, 9. Is that 8 numbers? Yeah, 8 terms representing my P of X and into 4 terms. 2,531. Okay, what are you going to do? How many of these are in those? How many? None. That is right. I cannot divide a lower degree by a higher degree because I can't do that. But let's finish it out algorithm-wise. What is 0 times this big old number? 0. 0 is a bunch of zeros. Okay. And what's my remainder? Over. Yeah. So it's 0 plus 2531 over all this big number. It's in the millions. So here's what I'm going to say. Let's just make a general statement. If we have a degree outside that is high divided by a degree that is lower, so the higher degree is on the outside than the inside, then our solution is 0. And then 0 times degree high is 0, right? 0 times anything is 0. So my remainder is degree to the low exponent. So it'll be 0 plus degree low to the low exponent over degree to the high exponent. Absolutely. So, just be kind of thoughtful because here's what I did not want to do. I did not want to fill in all those zeros. That would have been a really long problem. That's a lot of steps. So what's the answer to our problem? 0 plus degree low, that's a cubed, thank you, over degree high. Because it's not possible to do that division. And there you go. Do you have any questions? Homework tonight or this weekend. 4.2a is on Canvas on the 4.2 assignment. You are doing problems 1 through 12.